In this section, they introduce substituting numbers in for the variables that have exponents attached to them. And they call that evaluating an exponential expression. All you're doing is substitution there. To do these types of problems, you have a choice. First, you can you can substitute numbers first and then simplify, or you can simplify the expression first and then substitute your numbers. It makes no difference. You get the same answer in the end either way. I'll show you both for the first problem here, and then maybe we'll decide that one way is better than the other. One way usually is better than the other. Simplify 3s to the third t to the negative second power. And then they tell you that s is going to be equal to 2 and t is equal to negative 3. Well, I can just substitute numbers in right now. When I substitute, what do I have to use? Hopefully parentheses. So I'm going to write 3, parentheses, s is 2 to the third, parentheses, t is negative 3 to the negative second power. So I've just substituted the numbers in, and now I have to simplify. What is 2 to the third power? 8. Notice that I did the exponent first. In GEMS it says grouping symbols first, then exponents, then multiplication. I can't do this first. I have to do this first. So that is 3 times 8. What do I do with that? 1 over, right? It's a negative exponent. So that's going to be times 1 over negative 3 still to the second power. Once you've moved it, it becomes a positive exponent. And then we've got to keep going. We have an exponent sitting here in the denominator. So I have 3 times 8 times 1 over what? Negative 3 squared is 9. Okay, keep going. It's all multiplication now, so I can just multiply across. 3 times 8 is what? And then 24 times 1/9 is what? 24 over 9, yeah. Get comfortable with fractions. Been working with them all year. You should be okay with 3 times 8 times 1/9 being 24/9 at this point. What did I not do here? Accidentally. I got so excited about the 24/9. What do we need to do? Reduce. Always reduce your fractions. 24/9 has a common factor of 3 in the top and the bottom, so this is going to reduce to 8/3 is your answer. So that's one way to do it. Plug the numbers in right away and then work with the numbers. That's dangerous, though, I think. Because if you forget order of operations, it's easy to accidentally multiply here first, and that's wrong. You have to do exponents first. If you simplify the expression first, so we're going to take this and simplify it, see if maybe we like that better. If I simplify that, then what I need to do is draw my fraction bar, and where does the 3 go? On top. Where does the s to the third go? Also on top. And where does the t to the negative second go? On bottom. And what do I write? T squared becomes positive once I move it. Positive exponent. Okay, now that we've simplified this, we can now substitute. So I'll write 3 parentheses 2 to the third divided by parentheses negative 3 squared. So now 2 to the third is 8. And then I have 3 times 8, which is 24. Divided by 9. And then 24/9 reduces to 8/3. Same answer both ways, and we should get the same answer both ways. It's just one way we substituted the numbers in first. The other way we simplified it first and then substituted the numbers in, and then made our life, I think, a little bit easier. In my opinion, is life is easier if you do it this way. Simplify first, then substitute. It minimizes mistakes. So I like this way better. But if you want to go this route, I guess you can. Just got to be really careful. What? Try it this way. Once you get practice doing it that way, it's usually better. So, down here, we're going to let n equal -2 and w equal 5 for all 4 of these problems. Let's see if we can do that first one together. What should we do? You want to substitute right away? Not really. You can. If that's what you want to do, you can. But I'm going to go this route up here always, because it is the better way to go. So first, I want to simplify this. So what am I going to do? Draw your fraction bar, okay. Where's n to the -4th going? The bottom, and I'm going to write what? N to the 4th. Where's that w 0 to the 0 going? It goes on top, and I'm going to write what? 1, because anything to the 0 power is 1. Now I don't even have to worry about substituting in the 5 and evaluating it. So now I can substitute that stuff in. I'll write 1 over what? -2 to the 4th power. So what is -2 to the 4th power? It is 16. So you get 1 over 16. I know it's 16 because in my head I broke that -2 into -2 times -2 times -2 times -2. And then in my head I grouped these two together. -2 times -2 is 4. -2 times -2 is 4. And then 4 times 4 is 16. You don't need a calculator on a lot of these problems. So try to let your brain figure that out. But it is 1/16. All right, let's do this one over here as well together. What should we do? Huh? I still don't want to substitute. There's simplifying to do. Yeah, we got a negative exponent sitting here, and that's not very friendly to use. So I'm going to draw my fraction bar again. The n to the -1st goes where? At the bottom. And I'm going to write what? N to the 1st. But n to the 1st is just n. So I'm just going to write n. Where does that w squared go? It stays on the bottom. So I have nw squared. Well, what's in the top? A 1. Good. Because actually there was a 1 in front of that n that we left in the top. Now we can substitute. We have 1 over, what's n? I'm pretty sure that's -2. And then what's w? W is 5. So I'm going to write down 5 squared. But you're right, 5 squared is 25. Now you can do this last bit in your head here, actually. Most of you can. This is 25. What's 25 times -2? That's -50. So what do we have as our answer then? -1 over 50. If you can't do that in your head, then write down the step in between. The step in between was 1 over -2 times 25. So we went from here to here to here. It's okay to do some stuff in your head if you think you can do it. Let your brain do that, a little bit of growth there. And then you'll be able to do stuff like this in your head with confidence as you go on. All right, go ahead and do the last two here. Simplify them first, and then substitute numbers in, and then come up with your answer. And we'll talk about them here in a couple minutes. All right, what are we going to write on that first one first? N to the 0 is just 1, so I can write that as 1 over w to the 6th. Now I can substitute. So I have 1 over 5 to the 6th. And what is 5 to the 6th? 15,625. Is that a pretty big number or a pretty small number? That's a really small number as our answer. Good. And the last one, what should we do first? Okay, draw your division bar because stuff's going to move. W to the first in the top, and I'm going to write, what's W to the negative first? Is it W to the negative first up top? No, it's just W to the first or just W. And then the bottom is N. This guy does not move. That's N to the first. So it stays put. W divided by N. Yeah, now substitute. 5 over negative 2. Doesn't reduce, so you're done. The story problems in this section are going to give you the formula that you need. Population of marine bacteria doubles every hour under controlled laboratory conditions. So we went out to some pond and we scooped up some water and we brought it back and we stuck it in a closet somewhere and just let it sit. The bacteria in the water doubles every hour. The number of bacteria is modeled by the expression right here. They're telling you H is the number of hours after the scientist measures the population size. So H is hours. That's your time. That's your variable. Evaluate the expression for H equals 0 and H equals negative 3. Well, we can do that. That's kind of easy. So all I got to do is take 0 and plug it in for H. 1,000 times 2 to the 0. So what do we get? 1,000, yeah. 2 to the 0 is what? 1. And then 1,000 times 1 is 1,000. Okay, so let's talk about H equals negative 3. So this time I'm plugging in negative 3. 1,000 times 2 to the negative 3rd power. What do I need to do here? I need a positive exponent, so how do I deal with that? Division bar, okay. What goes in the numerator? 1,000. And what goes in the denominator? 2 to the 3rd, good. Then we just continue. We still have the 1,000 divided by what's 2 to the 3rd? 8, that's right. And now what's 1,000 divided by 8? 125. So we get 125 bacteria there. We get 1,000 bacteria here. So those are our two answers, but then it says, what does each value of the expression represent in the situation? So let's talk about what 0 means in this problem. 0 what? 0 hours since what? H is the number of hours after a scientist measures the population size. So if we put 0 in, then that's 0 hours after the scientist measured the population size, which means when are we? Like 0 time. It's right when we measured, if we were the scientist. Okay? What does negative 3 mean? Yeah, we've been saying a lot that you can't have negative time, right? Because time progresses forward. But when we're working with models, mathematical models, we can think about negative time, a negative 3 hours, as being 3 hours before where we are right now. So that means that this is actually 3 hours before we measured the amount of bacteria that was in this little sample of water or whatever it is that we're looking at. Okay? So it is okay to talk about negative time. It's just before we actually did anything, like in the past. Does that make sense? Okay. So your story problems, don't skip them. They're just like this. They'll give you the expression or the equation that you got to work with, and you're just substituting numbers in. It's no big deal. So you can do the whole section now at this point.